Hey everyone, welcome to the Anexipod, the official podcast for Anexinet. This is episode 36, recorded July 23rd, 2018. I'm your host, Ned Bellavance, Director of Cloud Solutions here at Anexinet. Here on the Anexipod, we talk technology for the enterprise, covering infrastructure, app dev, analytics, and anything else that is shiny. On this episode, we'll be talking to my homie, Mr. Michael Golub, Senior VP of Digital and Analytics Services and head of our ML task force at Anexinet. Welcome to the show, Michael.
Thank you, good sir. Thank you.
So you are a repeat offender.
Yeah, it seems no matter what I do, I wind up back in the Ned Zone, and
the Ned Zone. Maybe that should be the name of my next podcast. The Ned Zone. Welcome to the Ned Zone. So we had you on episode 4 of Anexipod way back in 2016, June of 2016.
Yes.
And you were talking Agile and DevOps.
Yes.
Which I think are still, especially Agile, near and dear to your heart.
Oh, absolutely. Still helping teams get and be agile, and still doing some agile advisory services out there in the world.
Right, but it's been a minute,
Yeah.
Time has progressed. So would you like to tell the listeners at home who you are now and what's cool and exciting that you're doing here at Anexinet?
Absolutely. So as I had said a minute ago, the agile thing is still very much real and alive for me, but these days the core focus, aside from trying to provide some solid servant leadership to the DAS team, which is our digital and analytic services, as you had pointed out, I'm really spending a lot of time with Team Malta, which is our machine learning task force at Anexinet, and also bringing some of the learnings that we have together to the world outside of Anexinet in the form of machine learning 101s. We're working on our first machine learning kickstart. That'll be a really interesting engagement to do and to get people kind of situated. A lot of people ask, where am I? It's like we're at a mall. And if you don't know what store you're near, it's really hard to find a guidepost as to where you want to get. So I think the kickstarts will help with that. And I've gotten myself tangled up in a couple of other things. I'm also sitting on the industry advisory board for Drexel University's information science program, which is fun. It's given me the ability to go back and interact with some students, which is really, really rewarding. That's my alma mater, so it was nice to get back on campus a little. And just for fun, I think I had shared with you before, I write music, and as a composer, I've been able to incorporate some machine learning-based tools into the cadre, and I'll name 3 of them now, and we can go into them more later. But Orb Composer is a machine learning-based composition tool that will generate melodies and harmonize them for you. And Neutron Elements is it's an interesting machine learning-based cleanup tool where you can run it on a track, and it will help find anomalies and smooth them out for you. You can set it for backing vocals or drums. And I'm also using NSynth, which is from the Magenta project from Google. And it's a synthesizer that takes multiple sounds and generates new sounds that are the equivalent combination of them, but using a neural network to determine what would be the sound that is properly in the middle of, say, a whale calling for somebody and a violin.
Those do have a lot of commonalities. Seriously, the sound that a violin makes if you're just drawing on it, and the sound that a whale makes underwater, there's some commonalities there. I could see fusing them together to make a wholly new sound.
Yeah, so it's pretty cool. So ML isn't too far from something I'm doing almost any point in the day.
Wow. Okay. So we dived in a little bit, but before we get too deep, we are here to talk about machine learning and AI. Those 2 terms are bandied a lot around marketing materials today.
Yes.
It feels like everyone's like, new and improved now with machine learning. The big sticker on the front of the box.
150% double AI.
Well, double nothing is still nothing, isn't it?
Yes. Yeah. Well, absolutely.
So I'm sure not only are those terms used in marketing, but a lot of the time they're used interchangeably, which I don't think is accurate. So let's just provide some guideposts for people out there. What is machine learning? What is artificial intelligence, and is there a relationship there?
Yes. So we're going to talk about AI and machine learning the way that we're going to talk about, say, fruit and grapes. And what I mean by that is AI, which was a term that was coined back in the 50s, actually, could be loosely thought of as a practice that allows machines to start acting like humans in terms of reasoning, knowledge representation, planning, and perception. So the thought behind artificial intelligence was to get machines to appear and to act and to perform in human ways, whereas machine learning is a subset of artificial intelligence that's really focused on helping us train algorithms, and train is a fancy word for allowing an algorithm to progressively get better and better and better at something. But I really don't use the word AI when I talk about what I do or what we do as a company, because I find that I like to reserve it for enjoyable moments, like when I'm at the movies watching iRobot. It really doesn't have a lot of place in industry. Right. Marketing would have you feel otherwise, that there is going to be the big Skynet takeover, but AI really isn't, as crazy as it sounds, something I'm very interested in. Machine learning, on the other hand, is something that's here and now. It's in industry, and it's more ubiquitous than we think. And the practice of it is something that you can apprehend. And as we go through our talk, we'll break it down a little bit. But at the end of the day, it's all about getting a model to have a representation of the problem space that's sufficient for it to make predictions in a reliable fashion. And that's at the end of the day, not to demystify it entirely, but that's really what it is. Can we get this thing to guess properly at some data that we hand it? And there's a lot of glorification around that, but that's really the nugget. If you can train that,
Okay. That's a great breakdown. And I think you sort of mentioned, like, machine learning and artificial intelligence are not new concepts. It's not something that just came around the corner yesterday.
No.
This is stuff that has been theorized about and put into some limited practice over the years. But it seems like they've really risen to prominence in the last few years. So what do you think is behind all that hype? What's going on there?
So it's interesting. Let's talk about what's behind the hype. But first, let's talk about how did it even get to this point? Because behind the hype are the things we discussed a minute ago, which is truly being able to train a model. But I'll tell you, Ned, how I think this all came together. And there's a lot of people that say something similar, and they may or may not give more weight to one component of this than the other. But three really important things happened. One was the researchers that had initially started looking into artificial intelligence and machine learning that were in Canada. Unlike the rest of the world, when it sort of fizzled out in the 80s, they didn't stop, and they kept doing their research.
Okay.
So we had a group that continued on, and that was really interesting, because if everybody had kind of backed away the way that the first group did, we would really be in a bad spot. So I studied what was called AI in college, and I graduated and suddenly saw that these algorithms were being used to basically have fuzzy logic components in an air conditioner turn on and off. That's not what I had dreamed of. So I just moved on and did other things.
That's certainly not the big sexy.
Right. So the Canadian universities kept at it. So we had some continuity, which was important. But then these two other things happened that were really cool, which was somebody had the bright idea of using a GPU, a graphical processing unit, to solve machine learning problems. And the reason they thought it would be a good idea is because, unlike a CPU that has maybe 4 cores, GPUs have hundreds, possibly thousands of cores.
Right.
And they're really handy when it comes to doing many, many, many small mathematical operations in an instant. So look at how all this kind of swirls together. The GPU makes it so we can solve the problems faster. Now, because we can solve the problems faster, our research gets better. And there's an example that I do. I do a machine learning roadshow, and I show people this live. We solve the problems faster because we have a GPU, and our research gets better. And a result of our research getting better, then our algorithms become faster. And these fast algorithms that are now operating on a faster platform make it so that you can do so much more in one cycle. So imagine if you had to run some code and it took a data run. Now suddenly something comes along that can speed it up 20 times. Well, that's what happened. And it wasn't just because of GPUs, but it was also because of a thing called vectorization, where we take a math problem and we impute it onto a matrix rather than looping through it. And you can do this matrix arithmetic wildly fast, even without using GPUs. And now you add GPUs to the mix. So it's this awesome kind of swirling bit where we've got faster chips and better algorithms, and the better algorithms make it so that we can do our work and the research moves quicker. And this is the third part. The research was shared amongst the data science community. So white papers that were fueled by both the new algorithms and access to cheap parts that sped up computers was shared openly amongst this creative society, thereby saving everybody else time and energy. So everybody kind of leapfrogged off of everybody else. So vectorization, GPUs, and open sharing, to me, are the three real big ones that help get us where we are today. Then you add to that some adoption, and you're off and running. Then the adoption in the industry has been going on for years. Data science has been put into use for years, but we really didn't call it that. We didn't call it machine learning. But all of the things back in the day when we just, our jaws dropped the first time you used Google Translate, all machine learning.
Right. So people are already training models, but
sure.
I'd imagine, like you were saying, before were essentially graphics cards. I mean, the GPUs were first designed and developed really to just handle the workload of rendering graphics efficiently on a screen, especially for really high demand applications or games.
Yeah.
In a weird sort of way, the gaming industry pushed this forward as much as anything else.
Oh yeah, I've always been very clear about it. You know, you've got Fortnite to thank for some of these breakthroughs. I mean, look at NVIDIA. These cards that were initially made just for gaming were hacked and repurposed, and now you have NVIDIA creating GPUs specifically for this use.
Right. I'm looking at one of their more recent cards, and the NVIDIA Titan V apparently has 21 billion transistors on it.
Yeah.
And what's interesting is, for a CPU, that's also could be thought of as a general purpose processing unit. Right. CPU needs to be able to handle a very large instruction set and do a lot of different things.
Right.
And we know, like, if you're a generalist and you have to do a lot of different things, you're probably not going to do any specific task extremely well.
Correct.
But if you have something that was purpose-built for basically doing vector math, which is what GPUs were originally sort of designed for, now you have something that is purpose-built to do a particular operation very fast, and you can fab out a ton of them on a single card.
Right.
So that's
fantastic.
It's the perfect setup, right?
Yeah, it's as good as it gets.
But those cards are still kind of expensive.
So they are, and that maybe dips into some territory about cloud, where initially, when those of us who were getting interested in this a few years ago started doing this hacking ourselves, and we downloaded our own little data science libraries on our own kind of rickety Python implementations, and then tweaked around with CUDA to try to make it all work so you could access your GPU. It was fun and it was exciting, and you're hacking the hardware and the software. And I hope that spirit continues. I have my own rig, and I'm really proud of it, but I don't really use it so much anymore because now, like our Machine Learning 101, it's now in SageMaker. It's on Amazon Web Services. Anywhere that has an internet connection, we can run that roadshow. It doesn't necessarily matter if our laptop happens to be acting up that day.
Mm-hmm. And you were sort of talking about a positive feedback loop where you can now run the algorithm faster, which means you can iterate on it faster, so you can improve it faster, which then sort of feeds back into the next generation of algorithms.
That's exactly it.
But there's still a barrier to entry for people who want to get into this. So anybody who's interested in jumping into machine learning, 5 years ago, let's say, they still had to have the money to purchase a high-end graphics card and a rig, and then the knowledge on all the hardware pieces and low-level operating system stuff to kind of hack it together, like you were saying, to get it all working before you could run a single line of machine learning code. Now that barrier is, to a certain degree, it's gone.
It has been largely erased. There's still the need somebody's going to have to spend some money somewhere.
Right.
But
obviously,
if you're not going to go with a fully decked out AWS instance, or you don't want to use Google Cloud Platform or Azure Workbench, there are companies out there like Gradient from Paperspace that would, for $5 a month, supply you with a moderately good machine that's virtualized, but on it would reside all of the data science libraries you would need. It's already kitted out with scikit-learn and TensorFlow and Keras, all the good stuff that you would use to do experimentation is right there. So it's a very different world.
Right. I think we jumped into sort of some of the jargon around it.
Sorry.
So no. I mean, it's clear that you're passionate about this space, and you're just like, ooh, I want to talk about this cool stuff. So what is sort of the, if you were trying to dip your toe into machine learning and AI, what are some of the tools you need to get familiar with and some of the terminology that comes up a lot?
Sure. So let's talk first about machine learning basics, and then we'll talk a little bit about the bare bones tools so you can play with it. So
Okay.
I came from a development background, which means that I have no patience, and I like to see things working poorly right away before I even bother trying to make them work well. All of us that do development, we were the ones where we would, before even finishing the train track, we'd have to at least get enough electricity to a few lengths of track to see the train move a little. And having
Right.
done that, now we want to build the rest of it. We need to prove to ourselves it's even a worthwhile venture.
Yeah,
So,
absolutely.
From that perspective, just to get a few things out of the way, in machine learning you have supervised and unsupervised learning. And you can think of it very simply as, in supervised learning, we're going to train a model to do what we want, and we're going to give it labeled data. And labeled data simply means I'm going to give you a data set, and let's say I want you to predict whether or not a tumor is benign or malignant. I'm going to give you a series of digital images, and I'm going to label them. Now, having seen hundreds of thousands of these and being told, this is malignant or benign, the idea is we're going to train the model. Now we're going to test the model by feeding it a series that's unlabeled and have it come back and tell us what label it is.
Okay.
So that's a classification example, and that's supervised learning. Unsupervised learning is where you take a very rich data set and you ask the model to help you determine subsets of it, and that's called clustering. So like Google News is an example. Many, many articles are out there in the world, and Google News uses a clustering algorithm so that when you click on a news article, you can very easily see other articles that are just like it. And it uses natural language processing and other things in order to pull that off. But all that stuff, in order to take steps to play around in that world, and there's many examples of both, at the very least, and I would tell you there's 100 ways to start, what I've seen work for myself and others is getting a reasonable grasp on Python. It's a wonderful language. It's self-explanatory. And the bulk of new materials and discoveries and white papers, if they're not in Python, they at least have a Python analog that somebody else decided to port to Python.
Right.
So if you learn Python and you don't have to get any better at it than knowing how to put enough Python scaffolding together to access data science libraries, to pull in data sets and to manipulate them, if you can get good enough at doing that, and you can often do that by mimicry, looking at other code, then you're getting to the point where you would be well advised to take a course. Now, I took Professor Ng's course. There's I forget if they call it a nano degree or a micro cert, but it's a certification in natural language. Not natural language processing. They call it AI, even though I would prefer to call it machine learning. But whether you do Coursera or Udacity or LinkedIn Learning or Lynda, which is a subset, however it is you go about it, getting your hands on Python, and you can download that for free. There's an application called WinPython if you're on a computer. You can download Anaconda for a computer or a Mac. All this is free. Get behind a course or two. Look at what's on YouTube. There's also Suraj Raval that teaches at a very fast clip. You have to slow him down to understand him. But you can really start to experiment almost for free. And there's a lot of coursework out there that if you're not signing up for the credit, you can take the entire course for free. You won't get credit, and you may not be able to take exams, but you can work through the whole thing.
Right. Yeah, the amount of free or very low-cost educational resources online is just outstanding.
It's just amazing.
And I got to say, so I do not come from a software development background. My primary background is, infrastructure, implementing networking, servers, storage, all that kind of good stuff that helps all the other stuff run.
Yes.
But that means that I'm more familiar with scripting.
Yep.
And I'm very comfortable with PowerShell as a scripting language, but I did recently, because I've seen Python appearing in a lot of things, said, I need to kind of learn a little bit about this Python. And I found the language so easy to pick up and start using.
It just jumps out of the page and bites you. It's just that easy. It's really, really simple.
Yeah. So, huge props to Python.
Yeah.
And then just knowing that if I do want to get into this machine learning thing, it's not like I'm learning C++.
Correct.
I'm learning what is a fairly friendly language to operate in.
Yes, it's a very friendly language to operate in. I would say the people that probably would have a harder time with it, Ned, would be the people who, unlike you, aren't coming at it from scripting or regex, but coming at it from another language that is very different in its syntax. So, for example, if you're using a language where spacing doesn't matter, you're going to get into trouble with Python because it's absolutely dependent on proper spacing. And there's things, it has its own idiosyncrasies, But if you're coming at it from scripting or from languages that are close to it, you're all set. Whereas if you're spending so much time in the trenches and all you're doing is C++, you're going to have to unlearn a couple of things and ease up a little bit in order to use this language.
Right. So I think that might lead us to the next set of tools, which is, if I'm using Python, I'm going to want some sort of development text editor that helps me with formatting and make sure that I'm using spacing properly. But I think there's also some tools that are very specific to machine learning and developing using Python on one of those tool sets.
Yes, there is. So let's get into the wonderful world of Jupyter Notebooks.
Ooh, I'm excited.
It is just that great. And for the geeky people out there, if you didn't get the shivers yet, once you get into Jupyter, you will.
And to Jupyter is spelled with a Y.
Yes,
correct.
It's like Jupyter. I don't know. You can't pronounce
Jupyter?
it. Jupyter. Yes. so it's Jupyter with a Y, and here's why it's brilliant. To the observer, when you're showing somebody a Jupyter notebook, they see a web page because it's rendered through a browser. But the Jupyter server that would either be on your PC or in the cloud is able to respond to cells on a page of a Jupyter notebook. So a Jupyter notebook gets rendered out as HTML5, but there are cells in it, and the cells have actual live running code. And when you hit Shift-Enter, those cells actually run, and you see the output from them show up right on the page. So for a teaching and learning tool, it's brilliant. And as I had mentioned earlier, with the white papers, so many things are in Python. So much of what you're going to find out on GitHub and on Kaggle are Jupyter notebooks. And Kaggle is a wonderful platform for competing for prizes and just for cred, doing machine learning solutions. So Jupyter to the developer is pretty cool because you open up this blank Jupyter notebook page and it's living in your browser. And you select New Cell. And in that cell, you can type in code or you can type in Markdown. The Markdown just looks like rendered HTML, and the cell looks like a great piece of code that in front of friends and family you can run lines of Python to thrill and amaze one and all.
Make hundreds of Julienne fries.
But it's I have to tell you, it's just fantastic when you're getting out in front of people that are new to machine learning. There's nothing like Jupyter Notebook to ease your way into it because you can include graphics and external links. So it's a rich environment, and it's not threatening. It's not like looking at a black page with multicolored text on it from within Eclipse or Visual Studio. Most people will run screaming from that if they're not developers. This is a little more friendly.
Right. That feels more like a homecoming to me, but I get the point.
Yes.
Jupyter notebooks sound a lot like, when I work in OneNote, and that has, some of those capabilities, but not nearly the level that you're talking about. But it is much easier to come to just a blank white page and here's a few suggestions to throw things to get started. It's that sort of like initial hand-holding that's just huge when you're getting off the ground with anything.
Yes.
So, maybe somebody's interested in getting into machine learning, but they probably have an application in mind.
Yes.
Most people don't come at it from a purely esoteric standpoint. So what have you seen are some of the real-world applications of machine learning that sort of businesses are looking at today to improve their business or their applications?
So there are a few, and I'm going to just run through a small list, some of which are from experiences that we've had at Anexinet with our clients, and some are just real world examples. I'm not going to put names on either of them just so we can kind of stay focused on the cool things versus who and where.
Of course.
But there are many cases, depending upon your industry, that lean in one direction or another. So I would tell you within banking, something that comes up a lot, and within insurance, is trying to do fraud detection.
Okay.
So in fraud detection, you can look at it as one or two approaches. You can look at it as an unsupervised approach where you're trying to cluster data and see if there are common things that would put somebody or a group of people in what we would call like a fraud category, or it could be a classification problem where you're deciding based on a model that you've trained, this is going to be fraud or not fraud. And in some cases, it's funny. It almost seems a little bit like Minority Report, where you're going to collect data that presupposes, or it's the signature of something about to come. And again, that's not to scare away our listeners. We're not guessing at whether or not a fraud will be committed, but we can take a look and do some, after the case, and we look at some of the data forensics, we can present a strong case as to whether or not, based on other examples, this is tending towards a fraudulent activity.
Right. And, well, I mean, the perils of being wrong in that case are much less than putting someone in prison for life.
Right.
So,
Right.
It's not quite as high stakes.
Yes.
But, I mean, you're saying in this unsupervised mode, you would present the algorithm with a ton of data that's unlabeled, in this case, whether it's fraud or not.
Right.
And it tries to cluster them into logical clusters, and then you could take a look at those clusters and now apply labels to it after the fact.
Correct. And it might come up with labels completely unlike anything we thought of because it's discovering correlations and inferences that we couldn't. And that's also used the case we're into now is something that CMOs are very interested in is market segmentation. What if we didn't realize it, but we have this niche group of clients, and they're all really into this thing, and we don't sell much of it. But as it turns out, this is a cluster, and they hang together, and they have many, many things in common. Maybe it's a good idea for us to market specifically to that market segment. So that's a clustering example.
Okay.
In healthcare, you're going to see, as we talked about before, in terms of trying to measure tumors, that's or classify them. That's a classification example, and it's binary. It's malignant or benign. There are algorithms that we've used to do anomaly detection. We are trying to figure out, is the thing that just happened sufficiently different from what usually happens so that this is an anomaly? And that can come into play with doing things like within healthcare or pharma, trying to look at the social sphere and determine, based on what people are saying about a drug, is it having unintended side effects? And you can collect that using unstructured data. You can look at Twitter and use natural language processing and some other classification schemes to very carefully determine how a drug is being reacted to by the public. And NLP is it's a science and an art, but think about this one. If you said, I took this medicine and got a headache, it's very different than I have a headache and took this medicine. Now, they could all be the same words, but just the way a thing is even stated, you have to be really careful as you're starting to train models and make inferences. So,
right, and that does get into what happens with false positives, and I'm sure the machine learning model is only as good as the data that you're feeding it.
Correct.
And so if the data that you're feeding it is already biased in some way, then that bias shows up on the model that you've trained.
Yes. So now you're touching on a very, very near and dear subject to my heart. And I could see the smile as you said it. I'm going to go on a tear. So there's bias with a little b. And when you're training an algorithm, you have to worry about bias and variance, and we'll leave all that out for now, but there's a lot of math that you have to get good at, and we could talk for days about gradient descent and all of that good stuff. Let's talk about bias with a big B. And this is where I get fairly animated. Bias with a big B is when, for lack of a better word, terrible things get into the data and train the model. And we've seen this, and some of the examples are so off-putting. I'll refer the public to looking up bias problems on the web. It's really awful. It's where algorithms suddenly react in a way that appears racist or sexist or ageist. And it happens because maybe there's either underrepresentation of a population in the data set, or the language that was being used to train the model had so much of that negativity. The model now is reacting in the way that the data has dictated. So here's what's really cool. You can actually fix it. There is a way to neutralize bias. And this is something, too, if people are interested, you can look it up. There's a sub-course within Coursera having to do with correcting bias. And you can fix it. And I'll make reference to a white paper. And I want to be very clear that the name of this white paper itself is somewhat offensive to my sensibilities. There's no bad words in it. So I'm going to tell you what the white paper is. I'll tell you that I read it, and it got me incensed, and I've started to do things about it. The white paper is called, I might be getting a few of the words wrong, but it's called something like Male is to Programmer as Female is to Housewife. And it's enraging. And
right, I mean, immediately visceral reaction on that.
Yeah, just enraging because it's so wrong. And the white paper is all about how a very popular data science library and algorithm, when tested and asked to make analogies like fork is to spoon as saucer is to cup, the words that were fed in, they asked for the proper analogy when you say male and programmer, what would happen if you put in female? And it came back with housewife. And that's not because computers are evil. It's because the language that had been fed to that algorithm was full of that type of awful assumption. Now, the good news is you can fix it mathematically. You can actually go in and tweak the model and make it so that the instance of the word programmer has an absolutely neutral lean towards male or female, that both are regarded in this algorithm as equivalently related to programmer, which is as it should be. So there's industries now popping up around taking the bias out of models, and it's really important because the implications are chilling. And I would just warn people, this is not an AI problem, this is not a machine learning problem, this is a human problem, because the data that fed these models was the stuff that was found out on the internet. And that, we have a chance now to clean up some of the yucky stuff that's out there and train machines to actually behave and act properly.
And to be clear, I mean, obviously you can fix the algorithm. You're not fixing the root cause. That's still an issue that needs to be dealt with. And that's a whole other series of podcasts that we're not even going to get into. But you don't want to perpetuate that behavior.
Correct.
And so by at least fixing the machine learning models and the algorithms to remove that bias.
To neutralize it, yes.
To neutralize it, you're not perpetuating it.
Exactly. Which to me is really a great thing, because if you think about it, without machine learning, you could say to somebody who's making these decisions, I'd like you to be fair and neutral. I'd like you to be open-minded. I'd like you to cast aside whatever sort of baggage you might have. And somebody might nod and say, yeah.
Sure.
In fact, most of the time, the terrible biases that are committed are done without people even knowing it, because they've been conditioned since birth to have certain feelings.
Right. It's that inherent bias. Yeah.
So while we often talk about how scary it's going to be when the machines take over, I will tell you this. I would rather have a properly trained algorithm any day deciding my fate when it comes to whether or not I get a loan or some of these other very important things in my life. And notice I said properly trained.
Right.
One that has had all of the bias and all of the natural human tendency towards stereotyping and all that awfulness carefully edited out of it, and you can do it.
Right. That makes me think of, on a lighter topic.
Yes.
There was IBM's Watson.
Yes.
Is an instance of machine learning and AI, and it was tasked with creating a cookbook.
Yeah.
And that cookbook was kind of like, obviously learn from other recipes, but kind of go a little crazy.
Yeah.
Remove some of those biases and just put interesting foods together.
Yeah, and then the pets started showing up. And
well, I mean, so it is interesting. So there were actual recipes in the cookbook that then they had chefs prepare.
Yeah.
And it turns out that some of the really unlikely combinations that a chef would never think to put together actually worked really well.
Yeah.
So it's removing that bias can lead to amazing.
Oh, sure, absolutely. It's so much like I know exactly where you're going. It's more than just simply fair. It's creative because it's removing these blockers we also have against the possibilities.
Mm-hmm.
Oh, that's really cool.
The possibilities are limitless.
Yeah, man.
So I think we talked a little bit about this, but I wanted to know if there are some common mistakes and pitfalls that someone can fall into when starting down the path of machine learning. And is there any words of wisdom or advice that you would give someone starting down that path to sort of ease them in the right direction or avoid something that you personally fell into?
Absolutely. I like to say, part of the reason I like to hang out with people that know more than me about a thing is, as kind of weird as it sounds, I don't want to make the mistakes they make. I want to hear about their mistakes.
Right.
So, and I often say that when I'm consulting, let me first tell you all about my failures. If I can save you from a pothole. So a couple of things. If you're starting off with machine learning, you might be starting off because you're curious and you want to experiment with this in a philosophical programming way. I'd like to see for myself if I could train a model. If it's from more of a corporate approach, you might be getting to the point where you realize none of the statistical approaches we're taking to this are working. We've gotten past the point, and now we need to try some machine learning approaches. Or it could also be, hey, I know my competitor has successfully employed machine learning, and I'd like to give it a try. So there's a lot of different modes and reasons for starting. And I would say for the first one, if you're the home experimenter, I would strongly suggest downloading an instance of Anaconda.
Okay.
And that's free. And it comes pre-packaged with Jupyter Notebook. I will warn you, though, everybody, if you do that, don't muck around with the base environment that it gives you. First thing you do is just create a new environment. You'll follow the directions. Because if you muck up your base environment, it's hard to get back. And then from there you can play around because it's Python-based. So I think you're heading in the right direction if you start playing around with Anaconda. If you're coming at it from the corporate perspective and you run out of ammo with traditional statistics, then a couple of ways to ease into it would be try some off-the-shelf things, from Amazon and Google and Azure, and you can get a sense of how a problem like yours would be solved because there's a lot of exampleware out there. Mm-hmm. At some point, you're going to have to do what I call the last mile, and that's where after you've trained up your algorithm, you're now going to have to tweak hyperparameters and make other decisions and possibly rescale your data. That's the tricky stuff.
Right.
But I wouldn't call that beginnery. So for beginner stuff, get your hands on a couple of those workbenches. And then from the last perspective, which is you've seen your competition employ machine learning to competitive advantage, I would say in that case, get in touch with people that have, gone a few laps on this thing and compare notes. If you have an internal machine learning team or a data science team that's coming up to speed, have them visit with others, especially if they're homegrown. If they haven't come to you as data scientists, have them visit universities and get together with others at conferences because there's a lot of good rubbing off that happens there.
Okay.
We have a homegrown team here. None of them started off as data scientists, and now we're competing on Kaggle. And we are always ourselves are excited to receive that stimulus from the market and from others. So I would say if you're growing your own team, make sure they get to see the light of day. And in all these cases, just to start off, Python's the way to go. And another bit of advice is do not feel the need to employ a multi-layered neural network just to say you did. Very often, the type of solutions that we're solving out there in the real world can be done with logistic regression or naive Bayes classifiers. These are really simple things. They're algorithms that you can describe and understand very easily. At times, neural nets do perform better. If you're doing work with imagery, there's a particular set of convolutional networks that just simply will do it better than logistic regression. But I would say avoid the need to impress.
Right. Don't overcomplicate it.
Right. It's already impressive and fantastic and great that you're experimenting with data science. You don't have to try to then use the most elegant, not elegant, but the most complex or most talked about algorithm out there. It's half the time you don't need it. I know that can be a little dissatisfying, but unless you're really pioneering and you're doing things, like guiding cars or airplanes around, very often a very simple approach will do. And by the way, the simpler the approach, the easier to maintain, the easier you can explain it to yourself and others. So you start getting into some deep waters really fast when you've got a lot of hidden layers, and when pressed, someone says to you, what was it about the last tweak you did that made this better? And when you can't answer it, now you're in some pretty deep water.
That's about right. Okay. Well, I think that is a great note to end on. If people want to know more about machine learning and more about you and kind of what you're up to in that regard, are there some places they can find you socially, online?
Sure. So I am on LinkedIn, and it's just my name.
Yeah, I'll throw a link in the show notes for that.
And I'm on Twitter. I think they link together. You can send me email here at Anexinet. I will write you back. And it doesn't even have to be because you feel like starting an official machine learning project. If you just have questions and you want to talk about it, I'm happy to discuss because there's so much ground we still haven't covered. And one thing I would say, just in parting, is we've spent a lot of people spend a lot of time trying to make machines seem more human. I would also say I think it's a great time now to just let machines be machines and be useful. And let's not try to fool people that they're talking to a human. Let's just be very clear.
Yeah.
I'm your bot, and I'm going to take care of you. And maybe a little less time spent on making it cute and a little more time on making it effective.
Useful. Yeah.
Yeah.
Awesome. Well, Michael Golub, thank you so much for being a guest on the Anexipod.
Appreciate it.
And that was our show with Michael Golub. Thanks to the marketing team for helping me pull this together. Thanks to Anexinet for helping produce this podcast. If you're looking for a company to help you with your digital transformation, then I would recommend reaching out to Anexinet, see how they can help. If you've enjoyed this episode of Anexipod, why not leave us a nice review on iTunes? If you're looking for more content, you can check out our sister podcast, Buffer Overflow. On the show, I am joined weekly by my co-host Chris Hayner to discuss what's new and interesting in the IT news sphere. You can find out more about me and what I am up to on Twitter at Ned1313 or on my website, nedinthecloud.com. Thanks for tuning in, and remember, IT moves pretty fast. If you don't stop to look around once in a while, you could miss it.